Welcome to the Deep Dive. Our mission today, well, it's about cutting through all that noise surrounding artificial intelligence.
Yeah, there's a lot of it.
Exactly. And we want to give you the only thing that really matters, the verified data. We're relying on probably the most authoritative source out there right now to show you exactly what AI systems can do, like right now.
And where they're still falling short.
Precisely. Where they are fundamentally failing and what those real-world implications, what they mean for you.
And that source, just so everyone's clear, is the Artificial Intelligence Index report for 2025. This isn't just some summary. It's a globally recognized resource.
Right. You see it cited everywhere.
Absolutely. Places like the New York Times, Bloomberg, and importantly, global policymakers actually use this. It helps set direction.
It's the benchmark.
It really is. It gives us that longitudinal, the long view in a field that's just moving incredibly fast. The data proves it.
And that speed, that's really the heart of it today, isn't it? AI is, well, it's absolutely not a story of what might happen someday anymore.
No, it's here.
It's what's happening right now. So we've pulled out 3 key trends from the report that honestly demand your attention.
Okay.
First, these just shocking performance gains, raw capability. Second, the explosive deployment of powerful AI agents and actual robots out in the world.
The physical aspect.
And finally, the really tricky parts, the friction points around safety, implicit bias, and this looming data crisis.
Big challenges there.
Definitely. Okay, let's unpack this, starting with just the sheer speed. The performance improvement the report documented over, the last 12 months?
Yeah, the jump in capability is, honestly, it's breathtaking. The report highlights really sharp increases on benchmarks that were specifically designed to push the limits.
These aren't easy tests.
Not at all. Things like MMMU, GPQA, and SW bench.
And remember, last year, these were seen as, the ceiling, right?
Pretty much. And now, well, they've been blown past. We're talking scores jumping nearly 19 percentage points on MMU, almost 49 points on GPQA, and a massive 67 percentage points on SWE bench. That one measures code generation.
So it's not just abstract math problems. This is practical stuff, too, like video programming.
Exactly. We're seeing huge strides in high-quality video generation. And yeah, models are actually outperforming human programmers on certain tasks, especially with tight deadlines.
Interesting. So what's driving these leaps? Is it just more data, bigger models, or something else?
It's partly that, but the report points to a key mechanism, especially for logic and math. It's something called test time compute.
Test time compute.
Oh.
So what is that in simple terms?
It's basically models think OpenAI's O1 and O3 that are built to sort of step back and reason through their outputs iteratively.
So not just spitting out the first answer that comes to mind.
Precisely. They kind of check their work, refine it. It's a more deliberate approach, fundamentally different.
Okay, so if they're thinking more deeply, how much better are the results? You mentioned math specifically.
The results can be really dramatic. Take Model O1. It scored 74.4% on an International Mathematical Olympiad qualifying exam.
74%. Compared to what?
Compared to the previous benchmark, GPT-4o, which only got 9.3%.
Whoa. Okay, that is a gigantic leap. From 9 to 74, that's real progress in mathematical logic.
Fundamental progress, yeah.
That kind of reliability is, well, it's impressive.
Yeah.
But there's always a catch, this deeper reasoning. It must come at a cost. What does the data say?
Oh, absolutely. It reveals a massive trade-off. Speed, cost versus depth of thought.
Right.
Enhanced reasonings is free. Model O1, the one that, nailed the Olympiad math.
Yeah.
It's nearly 6 times more expensive to run and about 30 times slower than GPT-4o.
30 times slower. Okay,
Yeah.
So you're really paying a premium, both in time and dollars, for that complex reliability.
A direct premium, yes.
And even with that extra cost, that extra thinking time, the machines still hit a wall sometimes, right? Especially with more abstract stuff.
They do. The report is clear on that. Models still struggle reliably with planning tasks like the Plan Bench benchmark. And when researchers create these really extreme tests designed specifically to find the absolute current limits, the gap with human abilities is still enormous.
Like what kind of tests?
Look at something called Humanity's Last Exam. The very best AI system scored just 8.80%.
Less than 9%. Okay.
Or another one, Frontier Math. AI only solved 2% of those problems. So yes, the models are climbing the curve faster, but they are nowhere near the summit of truly complex strategic reasoning yet.
That gap in strategic thinking, that feels like a good place to pivot. Let's talk about AI agents using this capability in the real world.
Yeah, that's the next logical step. And agents are showing, massive early promise. There's a tough benchmark called R-Bench.
Okay.
On short tasks, say, with a 2-hour time limit, the top AI systems score 4 times higher than human experts.
4 times. That's
Yeah.
huge for quick automation tasks.
Perfect for burst tasks, immediate automation, exactly.
And the report mentions specific examples, right?
Yeah.
Like writing specialized code.
Yes, they're already matching human expertise in things like writing Triton kernels, which is quite specialized, and they deliver faster and cheaper.
But there's nuance there too, isn't there? What about longer, more complex projects?
That's the key qualifier. The report provides that necessary nuance. When you increase the time budget, say, to 32 hours, human experts still outperform the AI 2 to 1.
Ah, okay. So human endurance, complex project management, that long-term strategy, we still have the edge there for now.
For now, the data says humans hold the definitive edge there.
Okay, shifting from software agents to the physical world, robots, self-driving tech, that's advancing rapidly too.
Hugely. We're seeing major milestones, DeepMind's Aloha Unleashed project, for example.
Right. What can that do?
It lets robots perform really intricate tasks. Things requiring serious dexterity, like tying shoelaces or hanging t-shirts on hangers. That's a big jump in coordination.
That is impressive. And what about autonomous driving? There's always debate. But what does the data in the report show about safety?
Critically, the safety data looks, very strong for autonomous deployment. Look at Waymo's numbers in the report.
Okay.
Over 25 million miles driven, rider only. Those autonomous vehicles were involved in significantly fewer claims than you'd statistically expect from human drivers.
So much fewer.
They reported just 9 property damage claims. The expectation for humans over that distance, 78.
Wow, 9 versus 78.
And for bodily injury claims, just 2 for Waymo versus an expected 26 for humans.
Okay, that's a massive safety improvement over the human baseline.
It really is, according to this data set.
Given those safety numbers, the economic push must be huge.
Undeniable. China is accelerating its robotaxi fleets like crazy. Baidu Apollo Go, Pony.ai, they're scaling up fast.
And then there's Tesla.
Right. The unveiling of the Cybercab, a vehicle with no steering wheel, no pedals, set for 2026 production, they say under $30,000.
That signals commercial reality isn't years away. It's basically here.
If we connect this to the bigger picture, the data absolutely confirms the economic flow is moving aggressively towards these autonomous, reliable capabilities.
The cost savings, plus those safety stats, it makes the case for deployment pretty compelling.
Almost irresistible for many businesses and investors. But, and this is a crucial but, this excitement around performance and deployment, it has to be constantly weighed against the non-performance beta.
The risks, the ethics.
Exactly. The report is very clear. Capability is soaring, yes. But the ethical safety and governance challenges what we call responsible AI or RAI. They're just as critical. And they seem to be scaling right alongside the innovation.
The data on implicit bias is particularly worrying, isn't it? Especially because it shows up even in the best models.
It's very troubling. Models like GPT-4, Claude 3 Sonnet, these were explicitly trained with techniques meant to reduce bias.
Right, they tried to fix it.
They tried, but they still show pervasive implicit bias.
So what does that actually look like? What kind of bias are we talking about?
The report gives pretty stark examples. These models disproportionately link negative terms with Black individuals. They tend to favor men for leadership roles. And associate women more often with humanities fields than STEM fields. It seems to exist at a really foundational level.
Suggesting the training data, or maybe the architecture itself, is overriding the safety tuning they tried to add.
That seems to be the implication. And it connects directly to how fragile safety can be overall. The report talks about shallow safety alignment.
Shallow safety, meaning it looks safe on the surface, but
it's easily broken. We've seen data showing adversarial attacks, sometimes really simple ones, like just feeding the model a few specific words first, can completely bypass the safety guards. Harmful output rates can jump from, say, a manageable 1.5% up to nearly 88%.
88%.
After just 6 tiny fine-tuning steps, the safety is brittle. What's fascinating here is, well, maybe fascinating isn't the right word, alarming perhaps. It's the emergence of risks that scale exponentially.
Exponentially, how?
This is shown by something called the infectious jailbreaks phenomenon. They see this in multi-agent systems.
Okay, systems where multiple AIs work together.
Exactly. In simulations, researchers found that compromising just one agent may be slipping at one adversarial image into its memory.
Just one bad input.
Just one. That can cause harmful behavior to spread, like a virus, across potentially millions of interconnected agents.
Millions? How fast?
In the simulations, near total propagation happened within about 30 rounds of interaction. It's systemic, exponential, self-propagating contamination.
That speed of contamination, that's deeply unsettling, especially with the push towards more autonomous systems.
It changes the risk calculus entirely.
Which makes a whole policy and regulation landscape even more critical and more difficult.
Yeah.
We saw the EU AI Act passed, right? That risk-based framework.
Yes, a major step, the first comprehensive framework in a major economy. And the UN adopted a resolution pushing for safe, secure, and trustworthy AI globally.
But in the U.S., it seems more conflicted. The report mentions California.
Yeah, there's palpable political tension. California's governor vetoed quite expansive AI safety legislation.
And the arguments were?
Well, proponents argued for really necessary safety guardrails and accountability. Critics, on the other hand, countered that the rules were too strict, imposed excessive standards, and could stifle innovation, particularly in the open-weight model ecosystem.
So that's the core tension right there.
Yeah.
We see these systemic risks, implicit bias, infectious jailbreaks, but there's also this fear of slowing down progress. How much should that fear outweigh the potential for automating harm on a massive scale?
That's the tightrope policymakers are walking. And the political friction is happening right at that critical point where the potential risks are becoming clearer and potentially catastrophic.
Yeah.
And compounding all this risk is another really practical problem, data supply.
Ah, the fuel for the models.
Exactly. Future scaling, which drives a lot of the performance gains we talked about first, might actually be threatened.
Why? What's happening?
Websites are increasingly putting up barriers, using things like robots.txt files, consent protocols, basically saying, don't scrape our data for AI training.
And this is widespread.
It's growing. And interestingly, the report notes OpenAI's web crawlers are facing the highest levels of these restrictions right now.
So if the main fuel source gets constrained, future gains could slow down or maybe become less diverse if they can only train on certain types of data.
Both are potential risks, yeah. It's a definite bottleneck emerging.
Okay, let's shift gears slightly. We've talked performance, risk. What about the positive applications, the breakthroughs happening now?
Right. The flip side of capability, science is a big one. AI's contribution is getting officially recognized. The report mentions Nobel Prizes linked to deep learning for things like protein folding.
And the Turing Award for reinforcement learning.
Exactly. Big scientific validation.
And in medicine, we hear a lot about AI helping doctors, but is it moving beyond just assistance?
The data suggests it is. GPT-4, just on its own, was shown to outperform human doctors, even doctors using AI assistants in diagnosing complex clinical cases in specific studies.
Outperform the doctors. Okay, that definitely shifts the conversation from just being a helper tool to potentially having diagnostic superiority in some areas.
In specific context, yes, it's a significant finding.
And maybe the most surprising thing in the biology space was that finding about protein sequences, the unintentional capability.
Oh, yeah, that's fascinating. A general-purpose LLM specifically, an adapted llama model, was found to have sort of accidentally gained the ability to optimize protein sequences.
Accidentally?
Well, unintentionally. It wasn't explicitly trained for that, but it turned out to be better at it than conventional algorithms designed for the task.
Wow. That shows how complex these systems are getting, developing useful skills we didn't even aim for.
It really highlights that emergent capability is a real phenomenon.
Okay, finally, let's just quickly touch on the economics. What's the business adoption look like?
Exploding. Corporate use of generative AI more than doubled year over year, jumped from about 33% of organizations surveyed using it regularly to 71%.
71%. Okay,
Yeah.
That's rapid uptake. And are they see actual value, revenue, cost savings?
They are. The report breaks it down. Most reported revenue gains came from marketing and sales. About 71% of respondents in that area saw gains.
Makes sense.
And the biggest cost savings, mostly in service operations, customer service, support about 49% reported savings there.
And critically, the job market.
Yeah.
Is it shifting to match this?
Violently shifting, you could say. Demand for specific, specialized AI skills grew dramatically. particularly retrieval augmented generation.
RAG, let's just quickly clarify that. Retrieval augmented generation, that's essentially connecting the LLM to a big external database, right? To ground its answers in facts and stop it from making things up.
That's precisely it. Grounding it in reliable data. It's absolutely core for enterprise use.
Okay, so demand for that RA shell.
Yeah. It grew by over 2,000%. 2,047% to be exact, in the U.S. labor market data they analyzed.
2,000% increase. Incredible.
And skills around multimodal models handling image, text, video together saw nearly a 300% jump in demand. The economic shift is happening fast, and it's focused on these practical deployment schools.
Okay, so pulling it all together, we've seen these incredible performance gains, real-world deployments from robotaxis to protein folding, but paired with these deep systemic challenges around safety, bias, data. It's a real duality.
It's fundamental tension. We know AI can tackle complex math now, drive potentially safer than humans in some contexts.
Yeah.
But we also have clear data that its safety mechanisms can be surprisingly shallow, and implicit bias is proving really hard to root out.
Yeah.
This raises, I think, a really important question. It's about that conflict between how fast the capabilities are scaling and how ready we are to deploy them responsibly.
Go on.
Well, the data on implicit bias of models still favoring men for leadership roles even after bias training and the fragility of safety, that shallow alignment, it really suggests that raw computing power is significantly outpacing our ethical frameworks and maybe our regulatory understanding.
So the tech is moving faster than our ability to manage it wisely.
It appears so. And if the most advanced LLMs, the ones explicitly trained not to be biased, still carry these systemic implicit biases, and if these interconnected agent systems we talked about are already demonstrating this potential for exponential infectious risk spread.
Right, the jailbreaks.
What does that mean when we deploy these systems autonomously in really sensitive areas? Think personalized medicine, high-stakes financial trading. How do we ensure they aren't just, automating and amplifying human errors, societal inequalities, but doing it at machine speed?
And how do you even check for those hidden flaws, the implicit biases, the potential for systemic failure that doesn't show up in a standard safety test?
Exactly. How do you audit for the problems that aren't immediately obvious, the ones buried deep in the system's learned patterns? That, I think, is the core challenge you need to keep watching.
That is the crucial question. And that's where we'll conclude this deep dive into the state of artificial intelligence today. Use this knowledge, think critically about it, and apply it to your own context.